Hello everyone, and welcome to the Solving Equations with Rational or Fractional Exponents video. This is something you may have seen before, but is definitely one that I think could use a little bit of review. And before we dive right into the equations, one thing I want to show you is if you have, like the first problem, if you have something like x to the 2/3 power, what that really means is the 2 on the top really means x squared, but the 3 on the bottom really represents the third root. So you could think of this as x to the 1/3 squared, or even as the cube root of x squared. So for instance, if I gave you a number like 27 to the 2/3, that would mean it would be 27 to the 1/3 power squared, or as you're going to see me do today, the cube root of 27 squared. And the number times itself 3 times, that gives you 27 is 3, but then if you square it, your answer is actually 9. So I wanted to briefly go over what a fractional exponent really does, that the bottom number is the type of root you're taking, and the top number is if you're squaring, cubing, raising it to the 4th, raising it to the 5th. So with that said, if we take a look at number 1, our goal is to solve for x. So I'm going to rewrite this problem just so it looks similar. Instead of having the fraction diagonally, I'm going to write 2/3 equals 9. Now, I think the fastest way to do these problems is thinking about inverses. This means you're raising it to the second power and taking the cube root. If we would like to get rid of the 2/3 on this side of the equation, we would find the reciprocal, and we would apply that reciprocal of 3/2 to both sides of the equation. It kind of makes sense. If you're squaring and taking the cube root, the inverse of that would be cubing and taking the square root. So what would happen is these would cross out. You'd be left with x squared plus 2 equals 9 to the 3/2. Now, as we did up here, what this really means is because the 2 is on the bottom, so that means the square root of 9 to the 3rd. Now, when you're taking a square root of 9 in an equation, remember that if it's a square root or any kind of even root, you have 2 possible answers. So this would really be plus or minus 3 to the 3rd. So let me write that here. X squared plus 2 would equal plus or minus 3 to the 3rd, which is the same thing as x squared plus 2 equals plus or minus 27, which is 3 to the 3rd. So because when I take an even root, I have to have both answers, that means I have 2 different possible equations. Either x squared plus 2 equals positive 27, or x squared plus 2 equals negative 27. So if I solve both of these separately, I get x squared equals 25, so x would be plus or minus 5 here. And here would be x squared equals negative 29, so it looks like I get imaginary answers, specifically plus or minus I root 29. So those are all my hypothetical answers. Just like the last videos, last couple videos actually, we're dealing with extraneous solutions. So it is always good to go back and check. The good news about this one is because you're plugging in positive and negative 5 into something squared, it's going to become positive. So if I check positive 5, that would be 25 plus 2, which would be 27 to the 2/3 power. So this means I take the cube root of 27, which is 3, and then if I square 3, I get 9. So this worked. So positive 5 and negative 5 are good. If you would like to check the imaginary answer, you definitely can. You could take I root 29, plug it in here for x, square it, plus 2 to the 2/3, and see if we get 9. Now remember, when you square I, that's really negative 1. And when you square 29, that's really 29. So this becomes negative 29 plus 2 raised to the 2/3. Negative 27 to the 2/3. Well, the cube root of 27 is negative 3. And then when you square negative 3, you get 9. So both the imaginary answers and the real answers check. Now, number 2, I would like for you to get a head start on me. I would like you to, just like this one, raise both sides to the reciprocal of 2/3 and see how far you can get. So please pause the video now and try number 2 on your own. All right, guys, so here's what I did to start. I raised both sides to the 2/3. So these crossed out, and I got x minus 29 equals negative 729 to the 2/3. So what this meant to me was the cube root of negative 729 all squared. Well, the number times itself 3 times that gives you 729 is 9, but it would be negative 9 in this case. But when I square it, it becomes a positive 81. Some of you might be wondering how come we don't have a plus or minus. That's because if you are taking an odd root, like a third, a fifth, a seventh, it's never going to be plus or minus. But if you're taking an even root, like 2, 4, 6, 8, you're always going to have plus or minus. So the answer, if you add 29, I got to be 110. If you got that far, good for you. Work. Because if I take 110 and I plug it back into the original, I get 110 minus 29 raised to the 3/2. This subtraction is 81 to the 3/2. And because it's an expression, if I take the square root of 81, I get 9. And then 9 to the 3rd is positive 729, which is not the same thing as negative 29. So even though this went very smoothly, this ends up being an extraneous solution. So the answer is actually no solutions at all. So the reason I picked this example was just please be aware that sometimes even after a lot of work, your answer is no solution. These next 2 examples are good because your goal again is to isolate the radical. And remember, these are really like radicals because you have a third root and a fifth root. So for both of these, I would suggest isolating. So for number 3, I would subtract 4 to get v plus 16 to the 5/3 power equals 243. And over here, I would subtract 7, divide by 2 before applying the root. Again, what I would suggest is pausing the video and trying as much of this as possible. So let me give you time to try number 3 ahead of me. So please pause and try it now. Okay, to check back in with you on number 3, if you raised both sides to the 3/5, great job. This would cross out and you'd have v plus 16 equals 243 to the 3/5, which would really mean the fifth root of 243 to the 3rd. So what number times itself 3 times gives you 243? Well, that's actually the number 3. So all of this, the fifth root of 243 ends up being 3, but then I still need to raise it to the 3rd. So I get v plus 16 equals 27. So you would get v equals positive 11. But again, it is always a good idea to check. So if I take 11 into the original, 4 plus 11 plus 16 to the 5/3, that would be 4 plus 27 to the 5/3. So 4 plus the cube root of 27 is 3. 3 to the 5th is 243. 243 plus 4 does end up getting me 247. So this checks out. Number 4 is another one I would like you to try first before I start it. As a hint to you, remember if you apply to the 5/6 power on both sides, the 6 ends up being in the denominator, which means you're taking an even root. So don't forget that plus or minus. So please try as much of number 4 as you can first. So please pause now. Okay guys, again, I didn't do the whole problem, but to just check back in with you. If you subtracted 7 first and got 128, great job. If then you knew to isolate the parentheses and divided by 2 and got 64, again, great job. Then I raised each side to the 5/6, so these crossed out. You get 2x minus 6 on this side equals 64 to the 5/6, which is really the same thing as 64 to the 1/6 power, or the 6th root of 64 to the 5th. Now, what number times itself 6 times gives you 64? Why, that's 2. So this side becomes 2 to the 5th equals 2x minus 6. 2 to the 5th, or 2 times itself 5 times, is really 32 equals 2x minus 6. Now, there is one thing that I purposely forgot to make a point. I don't know if anyone caught it, but right here, right at this stage, when I took the sixth root of 64, because it is an even root, this should have been plus or minus 2, which means this would be plus or minus 32. So that means you actually have two equations. 2x minus 6 equals positive 32. 2x minus 6 equals negative 32. If you forgot to do that the first time, I would star that and make it a point that, remember, write yourself a note that the sixth roots, you have to do plus or minus. So now if I keep solving, I would get 2x equals 38 here, and 2x equals negative 26 here. So I have two possible answers of negative 13 and positive 19. And so if I want to be extra careful and check my work, which is good for a test or quiz, the original problem, again, I'll write it over here, was 2 times 2x minus 6 to the 6/5 plus 7. That should equal 135. So if I take 19 and plug it in right here, we would have 2 times 19, which would be 38. 38 minus 6 would be 32. 32 raised to the 6/5. The number times itself 5 times. It gives me 32 is 2. And 2 to the 6th is 64. So then if I double 64, like it tells me to do, I would get 128. And then 128 plus 7 is 135. So this one checks out. Negative 13, let me scroll down a little bit here. If I would like to try this one with negative 13, I don't know why that keeps doing that. That is really annoying. So if I want to do 2 times negative 13 minus 6 to the 6/5 plus 7, that again should be 135. So 2 times negative 13 is negative 26. Negative 26 minus 6 is negative 32 to the 6/5. The number times itself 5 times, that gives me negative 32, is negative 2. Negative 2 to the 6th power, again, is 64. 64 times 2, again, gives me 128, and then 128 plus 7, again, is 135. So both of these answers worked. So again, please just be careful on examples like number 4, when you're taking a sixth root, or an example like number 1, when we were taking a square root. Don't forget your plus or minus. So again, guys, there'll be some cumulative review tomorrow, starting with the rational exponent equations. I will see you next time where we're going to be talking about U substitution. All right, I look forward to it. See you then.